Yes, sir. Yeah, sir, it's hard to understand like why we're using the specific row and some columns when calculating the p's. No, no, no. I don't understand why like P1 is A11 times B1. Yeah, but why are we sometimes adding and then sometimes like subtract? Yeah, it's still kind of confusing, but I'm getting it little by little. No, just like if I were to actually do this calculation myself, it would be hard to find out uh, which the columns and rows I'm adding. Yes, I think we're ready to start programming. Sorry for interrupting, sir. The people online are trying to join the meeting and they need you to let them in. Yes, sir. Because it's not returning anything. Okay.
Okay, guys, so we can continue. Yeah. Then you hear me? Are you here online, guys, as well? Yeah. Can we continue? So we can do the things now, and we started already to program this Strassen algorithm. So we created the main driver method. We put some of the matrices here, and we created a method multiply, which will multiply two matrices. And here we introduced like in the matrix in the method multiply, we introduced that we will return an array, and it will be integer array. Here we just define it, and here we need just to place the body of the how to multiply that. And first of all, we need to understand that here we will have again recursiveness, recursion, because we have a possibility to multiply matrices of different sizes. Like here is 2 times 2, but 4 times 4, 8 times 8, 16 times 16. And we need to consider one single thing before we start recursion. So what is happening when we have the size of the matrix one by one, because it is the simple one. Yeah? And if we have the size of the matrix one by one, then this is going to be the following. So here we can try to make how to determine the size if, and then here we can do this, and then else we can make different things. So here, if we have if, you see we consider here n is the length size of matrix A, and B, as they are all the same size. And here, if this one is equal to 1, so we can make it like that. If n is equal 1, then we consider some kind of this thing. Then how do we calculate the result? So then, if we have only the matrix 1 by 1, then what we have only actually one element, and this will be 0, 0, yeah, so the only element. So here we can make result 0, 0, 0 and 0 is equal to what? It is equal to A00 times b00. So this is the simple thing. Okay, so we can try to find out now this thing, and if we run it, but it will not go because here we will not have return, because what we have forced it to be. So here we have the fact, but we defined the matrices before it was like 2 3 and so if we make it differently, if we make it only one by one, then it will work, and then we will have the thing. But we are now not printing anything, so anyway we don't have any kind of result. So we need to figure out how to print the result, and let us now make a small program how to print the result. Yeah, and here please remember, so if you have to have this int, then here we can print the array, so it will be system out println, and here arise deep to string, and here we can write C. Yeah, remember that. So, and we include the arrays type. So now if we, and here we can write also println deep to string. We can also add some kind of information here. So we can add one more system out println, and here we can add the result is, and it will print the result. But now let us try to make very simple notation. So we will not take this into account, but we will take it like there is only one element, so we can put, for example, 4, and here we have like, yeah, so we need to introduce like this one, the one element only. And here also I will comment this part, and I will introduce here one element only, as if like, for example, 5. So if we start now, it will print us 20, because it shall print us 20. We can check if it does. So you see it prints us 20, because what we did, I just created the one-dimensional array. I just created the one-dimensional array, and one-dimensional array, you have it in our method, because if we have n is equal 1, then we have the solution. Understandable, yeah? But now we need to figure out what we do if we have a two-dimensional array. If we have a two-dimensional array, then we need to divide those matrices into different smaller matrices. Remember that, yeah? So, and what was the algorithm? Maybe you remember now. We have else. So here we have to divide the elements into smaller matrices, and what we have to do. You can see that here, remember, when we had the matrix A, I need to divide it into 4 parts. You see? I need to divide it into 4 parts. And now let me return back to not this 2 and 5. I don't need this anymore, because it is like was to check. Now I need to uncomment this part. So we have this matrix, and now we have to find out how to solve it. So we need firstly to find the way how we can denote those guys, like these guys, A, B, and so on. So we have 8 different variables. So now let us create the arrays. So first of all, we will create here, let us create the arrays. So we can make step 1, because this is the basically the method. And here we will create, we will divide matrices A and B into 4 parts, and then here what else we can do, and we store the values in auxiliary arrays. Yes, arrays. So now we have to define one array which is called A11. Then we need to define this array. So how do we make it? So it will be new array, but we need to create the size. And what will be the size of the array? We need to take this amount, but we have to divide it by halves. Yeah. So here we will make it n over 2, n over 2, and n over 2. Is it clear? Now, how many such arrays we have? We have the matrix A. The matrix A is here, and we have 4 parts. So we have A11, we have to have A12, A21, and A22. So we need to put it like this. So I will copy that part, and I will just insert it 4 times. And now I just change the indexes. So index 11, here it is 21, and here it is 22. Understandable? Yeah. So this is, I create subdivision. I subdivide the array. So I will make them smaller 2 times small. And the same I need to do with B. Do you agree?
Yes.
So because we have the matrix B. So I will use the same, and now I will just substitute this B. This will be B, B, and B. So I have basically 8 different arrays. Because remember, we had it before here. We had this part, this part, this part. And now I need to program this piece, yes, these things, and then I need to program those things. And now we have to find the way how to fix it, because I need to place the values inside. I have done it, but I need to place the values inside, yeah? And I need to create some kind of a function which will be splitting the values inside there. Do you understand? So I want to create the function which will split the matrix A into those things. So I will just call the method split, yes, split. I will call it the method what kind of information I need to be there. There should be the matrix A itself. There should be the new matrix A11, for example, and then I need to know the coordinates start and end from which one I shall start in order to fill it. Do you understand? Because what is important when you have the matrix, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 2, 0, 1, 3, 5, 6. So you have the matrix 4 times 4. You split it into 4 parts. So this will be A11. Yeah? And you have to start from 0, 0 and go forward. It will be 0, 0. You have to know which will be the initial coefficient. Yes, so then because initial coefficient x and y. If you take this matrix, it will be initial coefficient in x, it will be n over 2 already, yeah, plus 1, and then here from 0, etc. And then you need to know what is initial coefficient. So here I will put it like 0 and 0. So let us program firstly this one. You can see that split one is not taken, so we need to go and see what kind of method is done there. Yes, so we have to create a method for split. I hope you understand it. Yes,
yes.
You need to create a method for split. So then we need to create a method for split. So here it is method int, but I will make it like this here, also with the split, because this method shall be defined, and it will be also the method with arrays. So it will be public int, but I wouldn't say it's int because it will not give us a result. But if we don't give a result, how we define a method? It is void. Yeah. So we will define public void split, and here we can write some kind of information there. So we can create int. It will be some kind of matrix P, for example. It doesn't matter what kind of matrix we can have. we can have the matrix which will be firstly initial matrix, yes, and then the final matrix, yes. So the matrix, I will write it int C, for example. There are two matrices, and then I can write initial IB, so, and JB, so that you just start from this, from which element, yes, you start, and JB. So then it will be the following. So we have the method, and of course we need to open and close these brackets. So here we are going to find a way what we can do here. So what we do in this method? In this method we fill the corresponding matrix with the numbers, yeah, with the numbers, with the respective numbers from parent matrix, yes. So we have parent matrix A, or so it is like the parent matrix and the child matrix, I mean, yeah. So it is parent and child, so parent matrix and the child matrix. And so now what we can have to do, we have to define how many rows and columns there are in the matrix, basically C, and we have to define the cycle which we will go through both of them, through I and J, because we have, like, how to say, we have to make the following. So here we will have to make the child matrix will be equal to the parent matrix, right? Like that. It will be like, but we need to put it into the cycle. But what we have to do in the cycle, we need to go inside the cycle all the time so that we can insert the right one. Because we have, how to say, we have the matrix C, which is defined here like that, A11. We know the size. This matrix C, we know we have to go through that, and we need to take the elements from the parent matrix and write them there. Yeah, so this is like important. So now we need to figure out how to do it. So I have here this kind of model which we need to do, and here we can put, for example, something like ij, and here it will be ij. So I can say I1 j1, yes, and then it will be here I2 j2, yes. So this we are going to have, and then now we have to do very interesting cycle. So let us try to see. First of all, we need to go for what? For the columns. So we take the row, we fill the columns. So but we will have two cycles, one cycle, and there is another cycle, and then here we are going to have this part. I hope you understand. This is very simple, to fill the array. But the thing is that I want to give you a knowledge how to fill the array in Java. It's very nice that you can iterate accordingly in parallel to all the things. Like you can iterate for, you see here is I1 J1, so this is like I1 J1, and you can say you can iterate here for you see, and here I2 J2, so these are like you can in one cycle simultaneously change two variables. It's like I will define here int I1 I2 like this, yeah, so there will be two variables, and I1 will start from 0. It is always starting from 0, but I2 will start from the fact which you put here, from this part which you put here, because you put it from the parent matrix. Your parent matrix is not starting from 0 always, because if you want to start writing from this, you need to define the place from which you start, and you define this place in the method. So here I will write the thing which I here IB. So I will start from IB. Understand? So this is the fact what you do here. So it means that I hope you understand this part of code, because here you have in the cycle simultaneously you change two iterations. One starts from 0, another can start from 0 or from 3 or from 2 or etc. And so the same will be with J. And then here you have to put two conditions or one condition, it doesn't matter. So I will put one condition, which is I1 is less than C dot length, because it means that you can go only until you have filled the child matrix. And then here, of course, you have to iterate both of them by plus plus. So I1 changes plus plus and I2 also changes plus plus. Here, guys, you can see a very good example of the cycle with two iterations. We have never done this before, but here you can see that. It is very good way of writing the cycle where you have two iterations. In Java it's possible. You can study then afterwards if you like your C# or C++. Is there an option, or is there an option? You can study that if you want. So I will do something similar with that, but I will copy that here. Or maybe let's start from scratch. So here I will do J1 is equal to 0 as well, yes? And J2 is equal to JB, right? So this will be, and then again we just make the same way. So it is like J1 is smaller than C dot length, yes? And then what we have, J1 plus 1 plus plus and J2 plus plus, yeah, J1 and J2 plus plus. So you see, this method split is very simple.
Yes, sir.
It's very simple. And now we have written this split, and we can split whatever we want. Do you understand that?
Yes.
So it means that now we can try to make it. So that it means like split A111. So and then let us double check how we do that. So we need to make sure everything is fine. So we will write, it will be array 11. So now I will make system out println, and here arrays deep to string and A11. Yeah, so we will just write it. And you see we have 0, 0. So what we can check, we have here our A11. Now if we launch it, how do you think what it will launch? It shall give us 2, only 2. Let us check. You see it gives us 2.
Yes, sir.
Yeah. Now we can try to put split. We can try to put split here. Which one you want? Let us take here 1. So if I put here 1, the row 1, what will it give us? Starting from the row 1. Starting from the row, it shall give us, if it initially was this part, it will give us 3. Yeah, do you see that? 3 and 0, yeah? No, wait. No, it gives us 5, because the row is 5.
5.
Yeah, and this one is 0, yeah. So let us see, it should give us 5. Yeah, it gives us 5. So now we can try to see what it gives us if we put here also 1. Then we will start exactly from the end. It shall give us 6. Yeah. You see it's 6.
Yes.
And if I put here 0 and 1, it will give us 3, yes? it works well. It's interesting, you see, the algorithm itself may be heavy, but if we do it step by step, it's very interesting to see these little things, how it's done. And then you are learning how to understand the big algorithm by putting them step by step. And yeah, so you see it's 3, so it works. But now let us try to figure out how it works when we have a larger matrix, because we can have 4 by 4 matrix.
4 by 4,
Yeah,
3
4
by
by 4. Well, 3 by 3, it will not split it exactly, because we have to be, now the algorithm works, we have to split it by halves. If we take a 3 by 3 matrix, then we split, we will lose one row, yeah?
Yeah, it won't be equal.
Yeah, it won't be equal. So we need to figure out afterwards how to think. I will give you like as a home task to think about that. So there is one way to add some zeros around, so to make it larger. So here we have 2, 3. Now we can have, for example, 6, 7. And here we can have 5, 6, 9, 0. And then you can put here 1, 2, 3, 4. Yeah. And here we can write 7, 3. Okay, sorry. 7, 3, 1, 1. And now let me check. So you can, what will happen if you take 0, 0? How do you think, what will you return? If I take 0, 0, what will you have there? How do you think? If you look into that matrix, it is going to return us only this part, 2, 3, 5, 6. Let us check. It shall return us 2, 3, 5, 6. 2, 3, 5, 6, you see? You see that, yeah? And now, if you want this part to return, because we need to split it into halves, then this is how you can do. I hope you understand. It works. Yeah, so it works. Yeah, it works. Got it, yeah? Yeah. And now we are going to, Artyom, is it understandable? It is like you came a little bit late, then it's difficult to get maybe this Strassen algorithm. We are multiplying the matrices by the special algorithm. And this algorithm is described on the 75th page on the book which I uploaded in the introduction of the course. If you download it, you can see that. So we need to figure out now how we put it there. So we need to split other matrices. We split it only one, yeah? So let us now split all of them, yeah? So here, all of them. And you see the result is also, the resultant matrix is 0, 0, 0, so it's also making good. So now we need to split, I will print them all. So here, let me take another split, but here I will put it 1, 2, right? But if you want to put 1, 2, what coordinates you shall take? Here you have to take n divided by 2. Do you understand why? Why here is n divided by 2? Because look, you have, this is n. This is n. And if you case, n is 4. But now you have 0, 1. It is position 0, position 1, position 2, position 3. If you want to display this matrix, you put, here is also 0, 1, 2, and 3. So you put 0, 0, you start from this, go to this way, and go to that way, until n over 2. Remember that, yeah? So, because you have here defined the size of new matrix, it is the length of n over 2. You see here. Yeah, and that's why when you put into split, when you go to split, you take the size of the child matrix. You can see here, the length of C. So it means that you take the half length. And if you start from that place, then you take half length, you go 0, 1, 0, 1. But if you want to display this, you need to start from that position. And it will be, row will be 2, and column will be 0. But 2 is half of the initial matrix.
Okay.
So that's why you put n over 2. Because initially you put there n, but n is the length of the initial matrix A. And that's why here I put n over 2.
Yes.
So if I put now this way, you can see, so they are now the same. What is that? So let me try to figure out. Yeah, so here I have to do some kind of things maybe afterwards. Let me see. Y is the same. So here we have n over 2, and I need to write here maybe the fact is a11 is, yeah, and here I will write a12 is, yeah. So let me just drop it. And you can see now it is writing, but I have some doubts if, I know what is this, because arrays deep to string a11, but I need to write a12. Yeah, I'm just printing the wrong way, so let me check whether it's okay or not now, and I think it should be fine. You see?
Yeah, it's different now.
It is totally this way, yes, so here, but I didn't put the matrix. I will write the right matrix here so that you know which matrix we are now discussing. So this is, I will delete this one and we can write
Yes.
the right one so that you can compare and you can see the visual thing. Yes. Okay, and so the matrix itself is 2, 3,
6, 7.
6. You can write 6, 7. Here I have 6, 7, 5. Oh, wait. I'm too fast.
I think it's 2, 3, 5, 6.
This one, Artyom, this one.
Okay.
Yeah, because we have put it into program now. Yeah, 5, 6, 9, 0, 1, 2, 3, 4, 7, 3, 1, 1. And we have programmed that this array can be divided into 4 parts. Yeah, and you see it was very simple algorithm to split. So in order to split, you use these 2 cycles, but here is a good trick that you just compare the right ones. Yes, so you start one from one thing, another from another thing, and then you can compare. Very good opportunity to do that. And this works, and this is very nice. If you understand it, then it means that you can also use it afterwards. And here you can let us do the next one, so we can do the same. Now if we have a21, and how can we change it? Here should be n over 2, yes, and here should be 0, yes. Understand? Because we want a21. A21, this is this matrix. So the rows should be starting from the second row,
Yes,
and starting from the zeros columns going forward.
okay.
And here it will be 2, 1. And now the same it will be for 2, 2. So it will be 2, 2. Here I have to use both of them, right? Like this, and for 2, 2. And here 2, 2. And 2, 1. Let us check. You see?
Yes,
Everything is fine?
fine.
Fine. So now we know that we split it the same. And we have a very good function split. We can split any function now. It's just we need to make split, and that's all. So we don't need to do anything. Yeah. And you see, if I put a larger matrix, it will split it. If a smaller matrix, if it will split it. So it's a good. And now I need to do the same with B, right?
N by 2 and n by 2.
What, please?
N divided by 2 and n divided by 2.
Yes. Because I need to divide them all by 2. But here you can see that my initial matrix B is smaller. So let us see what will be the result. Yeah, it shall divide it also. So, but I need to make here b. Yeah. So here also b. Here should be b. 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 And here should be b. Here should be b. 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 It's easy to make it like this, but you have to be very careful. I know from experience, if you copy, then you have to always double check. It's a disaster when you do it automatically, but sometimes I can tell you that very often you need to copy the code somewhere, because when you work on large projects, for example, I worked on large projects in companies when you have, and you have to make, for example, one single button, and you have to attach single methods which are there. Then you need to either use the same methods or override them, or just copy and say, yeah, and then you need to say, here there's something changes, etc. But you need to be very careful when you copy, because if you forget to change one symbol, it can result in some kind of, it can call different value, for example, from different table or for different database, and etc. And so, okay, so now you can see if I launch it, it will work also for this, and you can see that something is wrong. Something is wrong. What is wrong there? I know what is wrong, because we have only one single thing. We have n defined only for a length, but b is smaller. Yeah, but in our matrix we agreed that we will make two matrices one and the same size.
Yes.
And that's why it is not working, because we have matrix of a smaller size and we want to have larger iterations. But when we split it, it becomes one element, but we want to write two elements. And that's why it gives us an exception, because you have index 2 out of bounds. So this is totally clear, yeah?
Yeah.
So it means that now we have to increase the matrix. Yeah, I will decrease the matrix here, because I want just to have 2, 2, and then later we will try with the larger matrix, okay? This one I can delete. I think it was like 2, 3, 5, 6 in our example, yeah? 2, 3, 5, 6, and this one. So exactly. And then now if we launch it, then it will be very simple. We can see we have split it to everything. Everything is good. Yeah, everything is good. So we can check. Okay, so now we have these things for multiply. So what do we do now? We have to return to our this part, but I have written it in Notepad, all the things. So for example, Artyom, if you how we calculate, you see we have to multiply two matrices. In order to multiply, you need to split the matrix into 4 parts. Then you create those things. You have to find those 4 things and those 4 things. We have already found them now. And then later you have to create coefficients. We have to create coefficients, 7 coefficients, by combining those matrices which we are doing. And then we need to find the same matrices afterwards. So understand? And so now we need to split them, and you need to subtract or multiply and do these things there. So we need to make those coefficients now, the 7 coefficients. You understand it?
Yes, sir.
Yeah, and you need to make the 7 coefficients, and you can see that here we have add and subtract. But we haven't determined the add and subtract method, so we will need to determine. We have the method for multiply. I think we have the method for multiply. This is what we did for multiply. We did, but we don't have the method for subtracting and adding. We have only the method split. So we will need to call methods add and add and then subtract, and then we can use the method multiply already, which we have. So now we need to create a new array. We need to create a new array after this part. It will be int, and I will have to call it somehow. I can call it p1. Okay, p1 is understandable. So this is the same coefficient which we did here. So we need to make it the following way. So I can put those things to my idea so that I can see what I'm programming, but of course I need to comment them, otherwise they will produce a lot of mistakes, yeah? Yeah, so here this is the thing. And we need to create HP1, and this is equal to new integer, yeah? But here, of course, what will be the size of it? But we cannot create a new one. We can already maybe start computation because it is also the same size. So we need to do the same. You see what you need to do? You need to multiply those things.
Yes, sir.
And then you need to multiply those things and you need to add something, yeah? So what we need to do here? We need to figure out how to do them. And look what we have here. You see, guys, that here we have a possibility to multiply and add. So we can write add and multiply, or we can have. How do you think which operation is more expensive, add or multiply? Multiply. And look what happens. If I do here 2 multiplications and 1 addition, but I can make here 1 multiplications and 2 additions. Look, and 1 addition. Look how I can do it. I can write it like this. It will be A11 multiplied by B12 plus B22. Do you agree?
Yeah.
But yes,
This.
will be
Hmm?
common in both of them.
Yeah, you have to subtract. Do you agree that?
Yes, sir.
So this is what we can do, yeah?
No.
Well,
It will be minus.
Yeah, definitely minus.
Here, yeah, I wanted to take, but we can do like this. Which operation will be better? I think this one will be better, but here, because here we multiply 2 times, it is more expensive than we say. And this is important to understand. When you create your codes, you need to estimate what mathematically you can do this and this, but you will do extra time.
Yes, sir.
And when you make a program code, you need to make it sure that you are writing accordingly to the best conditions. So your code doesn't have to make extra operations, and you need to write it as simple as possible, as faster as possible. But the way how you do it can be different. Yeah, can be different. So here now we do like this. So here we will create. We will have to multiply. We will have to multiply something, but what we have to multiply? We have to multiply the thing that A11 and now we need to add or subtract. We need to make, maybe I will write sub as subtract. And here I will create like B11, B12 and B22. So this is going to be the operation which I'm going to program. And now what I need to do, I need to define that, yeah?
Okay.
And how do I need to define? You need to figure out how you need to define that. So you need to figure out how to subtract 2 matrices. We also can program that. It's very simple, but we have to program that. So we need to go to public again. So here is void method. But now it is not going to be void, right? It's going to be the simple like a multiply. It could be public int only, not multiply but sub, yeah?
Yeah.
So I will copy that.
Yes.
I'll put it here and finish like that. So it will be not multiply but subtract, right? And now we need to program that. So what do we have to know about this way? Again, we need only 2 matrices, A and B. It doesn't matter which is A or which is B, because here we just put abstract names. But then we need to do what? We need to define basically How to multiply, how to make it? We need to go through all the array and just make it so this minus this, because they are of the same size. It's very simple. You have to have two cycles, and that's all. And then C is equal A minus B. The result is equal to C minus B. Yes, so we have to make a result there. Okay, so we need to write a return. We have to write a return, and what do we have as a return? We can make the matrix C, for instance.
C.
Yeah, and then before we do the C, we need to create the integer array. Yes, C is equal to what?
Is equal to the same.
We have to have new array, but we need to determine the size of it. This is important. Yeah, and we don't know the size, so we need to read the size. We can read the size from A as well, because A and B are of the same size. So we can write int n is equal A dot length, and then here we have n and n. So is it clear? New only. Yeah, like that. Okay?
Okay.
And now we need to have the loop for what? For
Multiplication, subtraction.
for subtraction.
Yeah.
For subtraction, what you need to subtract, you need to go through all I and j. So here you can define for cycle, and here one more for cycle, and here you will have Cij will be equal, which will be the first minus second. Yes, so Aij minus Bij. Yes, like that. Do you agree? So, but now we need to make here indices. So we can create I and j, right? I and j, I and j, and here the indices shouldn't be taken with different shifts, because they are coming from each corresponding element.
Yes.
So it is simple. So what we have to do here, we have to put here I, yes, is equal 0, then I smaller than n, right? And I plus plus, right? Very simple.
So please scroll up.
Scroll up, yeah, like that. Do you understand it? But here we need to define int. And the same we can do int j is equal 0, and j smaller than n, and j plus plus. So this is how we divide, yeah? Do you agree?
Yes, sir.
Look, please look at this code, guys. Please look at this code. If you understand it, online guys, if you understand it, please tell me, because it is important that you understand it. Do you get this? Artem, do you get it? Roman, do you get it? Do you get it? Okay, let us try to consider that one more time.
No, I get it.
You get it, yeah?
Yeah, I think I got it.
Yeah, because this is the way, one matrix. You need to make subtraction. What is? You need subtract. From this matrix, you need to subtract something like that, the same level.
Yeah,
What to do?
I think like explaining how we subtract matrices would help.
Yeah, how we subtract matrix? 2, 3, 5, 6 minus 1, 2, 3, 0. It is 2 minus 1, 3 minus 2, 5 minus 3, and 6 minus 0. So we subtract the corresponding elements. And that is why we write here Cij. This is the element ij. We take Aij minus Bij. And they are corresponding. For this, it will be this and that, because I and j are same for all three elements. Understandable?
Yes.
It is simple.
Yeah.
Yeah, it is simple. It is really simple. So if you understand it, you have to understand it. It's fine. It's
Yeah,
simple.
we've done more.
You've done more complicated
Yeah.
stuff, yeah. You've done a lot, my friends. And I really liked your homeworks, especially Artyom has submitted me the good homeworks explained, and there was also another, I don't remember, Hassan was submitted also good homeworks, and Ulvi, he is online or submitted good homeworks. I remember all these surnames because you all the time go in the same pace. Some of the guys submitting it later, but take your time, and if you don't understand, just ask me. Because, Artyom, was it difficult to understand that? Merge sort or something? How many hours you spent for that?
Not like hours, but I just needed to. I just went into debug and
Yes,
I
yes.
cycled through it
Yes,
like a
my
couple of
friend.
times, and I
Exactly.
started like noticing some things.
Yes, what you need is just switch on debugging and go through debugging. This is what I'm teaching you now, basically. Because when you learn algorithms, you just switch on debug tool and you go and understand step by step. And believe me, this is a very good skill, because when I do some real tasks in my work, I do debug every task. So I have a problem somewhere, there is an exception or something, then some kind of one task I solved, there was a zero somewhere appeared when you calculate. For example, I was working with the project which was with the POS terminals, and you just scan a card, you know, like a Maxima card or Rimi card. You scan a card on the pad, and then you have to get a discount. But when you finally calculate the discount, it has to take some coefficient from the card, and it appeared to be zero. But it happens so that when you connect to an external API to get, because it was like a pharmacy card, it was like not the Maxima card, but you buy somewhere in the supermarket, and it is a pharmacy card. If you have the special card, you get a discount on the pharmacy shops. It's in the US, yes, they have. And so it means that the person scans and the answer is received, but it is not going somewhere else. It is like -1 or 0, and then you don't have a discount and something like that, and you need to find it. And so in order to find, you need to find the place where it is in the code. And now we are looking with one class, but in that project there are hundreds and thousands of classes, and some of the classes are already, how to say, they already cannot be changed because they are already in the external libraries. You just download them, and if you find it, then you need to override that class, and you need to write again another method. So it's like total disaster. But you need to debug. And in our course, we are learning algorithms, and parallelly we are learning how to debug, how to do. And you see, you have debugged, you understood this way, and if you get used to debug the code, then you already get the skill which is needed for the program. And here also you see that afterwards we can debug if we have some time. But you understood it. Let's go further. Yeah. So now we have uh, we have uh, the thing like this. So we have split it into this part, and now we need to go to program that thing, and it works. Now it works. So we can multiply and we can calculate it. Let us try to calculate, let us try to print it. Yeah, so what is the result? And let us print system out println, and we can try to print system out p1, and now we have to write here p1. So we have to print out what is p1. We have to understand whether we are right or not, because we have calculated the p1, and the p1 has to be 8. So let us try to figure out if we have 8. Ooh. P1 is something like that. Yes, we need to use deep to string. Why it is like that? Because it is still an array. Even if it is one-dimensional array, it is still an array, and we just cannot make it like this. So we need to arrays.
Sorry, can I go?
Yes, yes, of course. Keep to string and p1. So this is like that, and let us now print it. So, and we have 8, you see? Perfect, we have it. So now we have to bring the next thing to life. So we need to calculate the P2. And now we will be easy. Why? Because we already have some kind of, we have to use the formula now. Let us try to figure out what will be the formula. I will go to this way. So I will just print this, I will cut this out, and I will put it here, because we need to figure out what is P2. Oh, okay, so this is like that. We need to figure out what is P2. And this was P1. This is P1. So I need to put them closer to each other so that you see the formula, yeah? So now P2 is like this. Can we simplify it? Yeah, we can do it like this. We can do, believe me, you cannot change places of them because it's matrix. If you multiply it second, it should be second. You cannot put it in front. So you can do it like this. It will be A11 plus A12 and multiplied by B22, like this, yeah? Okay?
Oh, okay.
You got it. So then, because matrices cannot be multiplied the other way around. If A is B, it is not B times A. But we are multiplying matrices. If we increase matrices, we multiply the matrices. So now here what we can do, how we can make it. So we can multiply, but here we can write add, yes, right? And now we can put here B22, right? And but here if we write add, it will be A11, A12, yeah? And now we need to program the method add. If you know how to program the method subtract, I think you know how to make the method end of work. How to do that? It is so simple. You just copy that and insert it here. Just write here add and change the sign. And that is basically all. Yeah? Do you understand it?
Yes, sir.
Because it's just adding. It's just adding. Yeah. So and then we will check now P2. Let us try to check P2. So P2 is equal to P2. We have the P2 here. What it has to be, we need to check. P2 shall be 0. So let us check if we have 0. Because when we do something, I advise that we have 0, you see? Good. So now we have a 0. Now what we go forward? So we need to go for P3. Yeah? If we go for P3, and you can see that here, for example, yes, so here I want to see if we have recursion. Yeah, you see, recursion already appears here. You see? Why? Because we call multiply method inside the multiply method.
Oh.
Yeah, because we all the time we call here multiply method, and when we look at our driver, so we say we have s multiply ab. We multiply, but inside we also multiply. But we already divide them, so this is nice. And now what we do afterward, as you see, it is not really difficult algorithm. We just and my task is so you understand the algorithm and you understand the way of programming, because this is one of the basic skills. You need to know what is recursion, and you can understand the recursion. We already have the third example with recursion. So here we have to go for P3. Let us go for P3. And okay, I forgot to copy the P3. No, okay, so then I have to copy that again. Control X. Where is P3? P3, and this one I need to delete. Actually, I will find it. I will take them here, and I will put them here so that all the time I will write somewhere in between those guys. Yeah, so that you have it. So think about how to program P3. Maybe you have an idea already. But it will be now easy because we already have written the methods for adding and multiplying and subtracting, but here there are only adding, multiplying and subtracting, nothing more.
It's B11 multiplied by A21 plus A22.
Yeah, only Artyom, you cannot change places. If B11 is why you cannot change places? Because if you multiply two matrices, A times B, it is never B times A.
It
Yeah.
will be
It will never
similar
like
to
this.
previous one.
Then A21 plus
A21
A22.
plus A22
Yes, it will be A21
like B1.
plus A22 and multiplied by B11. Yeah, like that. So, and then we have to program that. So I will copy that stuff here. So now not to rewrite, here will be P3 and P3, and here P3. But now what shall I do? I shall multiply. Here I will have add 2 1 to 2, yes, and here B11, right? Very simple. And now we can run. We can see what is that P3. We need to check it. All the time we need to check. It is 22, and we can try to figure out it is 22. So this one is done. This one is done. This one is done. Yeah, just a tick. Okay, now we have to find P4, which is minus 6. So what about P4? So let us speak about P4. Can we simplify that? We can simplify it to 2 multiplied by B21
plus
B11. Okay. And now we have this part.
Wait, isn't it subtract?
Yes, my friends. Thank you, Justins. Yes, so it's subtract, exactly. And now we multiply. So what we do here, we just say A to 2, and here subtraction, and B to 1, and B11. You see, like that. And here now it is P4. This is P4. And this is P4. So if we run like that, so what we have, minus 6. It was like that, right?
Yes.
Yeah. Okay, so now there is a chance that we finish that algorithm today. Yeah, okay, so then now the thing is that, but initially it was too hard, right?
Yes.
Yeah, it was really.
We learn from
Yeah.
simple steps.
Yeah, so this is like, and here we have P5. So you just think about what we have for P5. And here we have for P5. And now you see here is a little bit more difficult what we can do there for P5.
Can you show addition again? Because
Addition algorithm, yeah? Yeah, Tom, it's very simple. It's like the subtraction. The only thing we just changed it add, and here we change it to plus because it's totally the same.
For some reason for me
It doesn't work? It is totally the same like
yeah, I know,
Yes, sir,
but
but
for some reason where I use addition, it just gives 0.
Okay, guys, please have a look how to make P5, but I will help Artyom to deal with the problem. Yeah. So just try to figure out how to make it. So what was that? You have addition, and you have some it is all the time 0. It is like you are looking now for P2, yeah? Add. Okay, can you? Addition. No, it is not have. Yeah, but what are your initial data? The same? Initial data, you mean, what are your initial data for? You have the same. Here, all is fine. All is fine. And here you have multiply. And here, P2 is multiply, add, and div to 2. Arrange div to 2. And 2 multiply, and here system out into n. Div to string. Everything should be fine. And you are printing, it is 8 is okay, but 0 is there. So, but everything is printed normally here. Then the problem is in addition, probably. What you have in addition, you have here just can you print out also just addition? Just you know you can print it that plus like this plus add. Let us take A11, A12, yes? Now let us run it. But it will not be good. We will have to put it add div to string, otherwise it will be. You can, no, you know what you can do? You can control X and erase div to string and here control V. Now you can. It's 5. So it calculates. Then the problem is somewhere in the multiplication. What about multiplication? We have A times B is okay. And then multiply, yeah. B to 2 is not 0. It is 0. But it should be 0. One of them should be 0. I have P2 is 0. I have P2 should be 0.
Yeah, but P3 is not.
P3?
Oh, because it didn't change.
It didn't change.
Okay, good.
Wait, you changed this?
I didn't change.
Yeah. You see, you didn't change that.
Good.
It's B11. Okay. Yeah, this is what I'm talking about. When you copy, you need to be very careful when you just change everything. So this is like extremely hard. Okay, and now have you managed to find out what is there? Let us find what we can do here. We can. What we can do? This one goes well together with that one and that one.
We have to multiply for like 2 times.
Yeah, but no, A11 is here, A11 is here, and here is A22, A22. So we need to add. Oh my God, it will be like a tough task. So here, look what I do. You need to do the following. Firstly, you add, and there are two guys there. The first one you multiply. you multiply, and here you multiply A11 and add
B11.
add B11, yeah, add B11 and B22, yeah,
And then
like that, right? And then you add A22. No, here you need to multiply again.
A22
Multiply A22
and then
and
add
add
B11
B11 and
B22.
B22, yeah. And it's important to keep the order. So here this one is coming first and here this one. Okay, now we calculate. Let us try to see whether it's right. So it is 16. I think it's right. Yeah. And you see that's important. Before you program, you need to make an example to check everything. Yeah, without this it's very difficult. You have to compare the results, you have to test. And that's why when you do in real tasks, you need to write automated tests sometimes. You need to write tests as well. When you do some methods, some program, you can write a tests and check everything.
Test cases.
Yeah, test cases. Have you had some?
Yes, sir, we are currently studying it.
You are studying this also. You're writing test cases.
Yes.
So, yeah, you see. So this is nice. Okay, so now we can go for P6, and we need to take the P. Oh, here should be P5. I'm sorry. So it's all the time P4, but it's a minor mistake. And here should be P6, P6, and P6. And here now we have to find out what is P6. Yeah, so this is P6, and you can see that here we need to delete this formula, not to mix anything. So do you see any kind of thing here? This one can be taken out, right?
Previous one.
And this,
we have to subtract.
yeah, and we need to subtract, but if we do subtraction, we can do like this. I will rewrite it so that, because it will be difficult for you to understand probably. I'll write A12 multiplied by B11, B21 plus B22, and here minus, but here will be A22 multiplied by B21. Oh, this is interesting. Look, B21, and here will be plus B22. And look what is happening here. This is very nice. What you see there.
And the brackets are also same.
But there is also the same, I think. No?
No.
No, it's the same here. We can maybe make it even more simple. This is important. Look, here what I can say, this is common. Do you see that?
Yes.
It is common with them. It is the same.
That's what I'm saying. The brackets are also same.
Yeah, and here we can say this one minus this one multiplied by that one. Do you agree? Do you agree with that?
Yes, sir.
This one, this one, this one, and this one. And what can we do about these cases? You can see the same way. You can see what is the same here. I will write it A11 multiplied by B11 plus B12, B22, and here plus A22 multiplied by B11 plus B22. And what we can do, this is the same, so here we can write like this, plus A22, and then it's gonna be okay, yeah, like that.
Yes.
So can we rewrite it maybe then afterwards? It will be better, because we have multiply and multiply, but we will have only one multiply again.
Yes.
So let us delete that long stuff, because we really will do it better. So we'll multiply, and here we will have add A11 A22 and add B11 b to 2, right?
Yes.
It's much better. And then here we can do in the similar way, I think, yeah, we can multiply. Only there you have to subtract, yeah?
Yes. In place of that we have
Multiply, and here we have subtraction of a12, a22, and here we have addition of b21, b22. Let us check. Oh, sorry, it should be large letter. So let us check. 16 and minus 3.
-3.
It was minus 3, I guess so. Yeah.
Yeah.
So we have to get minus 16 for the last one. So let us take the final one. It's P7. So here we need to delete it. And here P7. So here what we can do here. It is, I can see that A11 can be taken out. And here is B11 minus B12, yeah. And here minus, and maybe Justinus, you can see now a little bit like more interesting things, because you asked before why exactly like these coefficients, because we have just done some kind of recombination, and then maybe there is some sense we've already seen. And here should be minus A21 multiplied by B11 plus B12, yes, because minus and minus give us plus. And then here we need to take again, so this is the common, so we have the subtraction, so here will be minus A21, and this one disappears, yeah? So this is like that. So again we have multiply, here we have subtraction, and here we have A11, A21, and here we have again subtraction, right?
Yeah.
Again subtraction, and here B11, B12, yeah? Like that, okay. So let us double check. What are the things?
No.
It's 6. Oh,
It wasn't 6.
it wasn't 6. Let us check what we have.
Minus.
It's minus 18. And this is the fact now. B11. 1, 1. 1, 1, B11 minus. It's plus here. Yeah, it should be plus here, my friends.
Yes.
No, wait. No, here should be plus.
So we can't take common.
Here should be plus. And there is plus all the time, because here we take minus, but there will be plus. It's all the time plus. It should be plus there. So here we have to add for sure. Yeah, this is you can check it. It will be plus. It's minus 18. Yeah, I see that there is. Okay, so this we've done it. Very good.
Yes, sir.
So what is happening now? We have to create now this we need to create those four. Now we need to create those four guys. Those four guys we need to create. Yeah. So we need to take it out. And those C's we have to create. And then we have to join them. And then it's finally done. So we have to do this way. So we need to... Yeah, and now here we can write the following. So here C11. So what is this? We have to write int again. We need to create new C11. And what is that? So it is like you can just put it like that. What is that? Yeah. So we need to add, but you remember it's not like plus 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 because it is our operation plus we define. So we just add, and here how you do that. You need to figure out how you do that because what you add, and you can add only one thing there. You cannot add two, three things together. Yeah, it's not like that. So what you have to do. So you need to put add.
I'd say we can put like subtract and then add to halves.
Yeah, it could be something like that. So we have add,
So
add, subtract, and add. So we have to deal with that. So first of all,
I'd say, can I go?
yeah, yeah, you can go, you can go there.
So
You can make it. You can make a program here.
I just want to visualize it. May I have a
Ah.
marker? Thank you. So I think that it's easier to imagine those two as like halves. So this whole thing is like a
Subtraction.
a
Yeah.
subtraction
Okay.
with two
Yeah,
additions.
I agree. We can do that. Yeah. We can write subtraction, and here we have add and add. Yeah. So here we can write P5 and P4, and here.
E2.
But no, dear, it will not work. It will not work
Why?
because because if you subtract all of them, there should be minus as well. So maybe some other way.
What is the result supposed to be?
Result? I will show you. The result shall be in C11. It is 7. So it's gonna be. I advise that this one we can go, or maybe you know what we can do. We can do like that. So we can take this addition, and here we can have addition, and here subtraction. So addition, subtraction, and addition. So I can put here addition. Here I can put P6. No, here I just put P6. Here I put subtraction, and here I can put P4, P2, and here I can put addition, and here P5, P4. Okay, do you understand? And then I can system out. I have to receive 7, so we can do like that. We can check. It is 7. Do you understand it? No? Okay, give me your version.
Give him.
No, no.
Yeah, I'll give you a minute to take your time. Yeah, no.
So yeah, the problem with this is that we have to. Um, mm, it's not like in math when you can just take something in parentheses and the operation will be first, even if it's not first. We have to do something like left to right in order.
Yeah, but the way I wrote it, it's not the only one. You can do the different way. You can start from that way as well. So it's up to you. But if you want, you can. You can. Your version was also nice, but you didn't consider this one because you subtracted this all. But if you subtract the sum, there should be also minus.
Yeah, I agree. I understand the way you do it.
Yeah. This is the only way which I want to abstract about your idea, because if you subtract this sum, then here should be minus, otherwise it will be plus. So if you agree to mine, you can do, but you can also do a different way. You can add this one plus this, and then this one is here you have the difference between this and that, and so on. So let us try to find the next ways. Yes, so we need to figure out. The next one will be easier. Yeah, because there are only two of them. So it is C12. It is basically addition only. And here we have addition only. So here will be P1 and P2, right? So it's very simple. We can double check. C12 shall be 8. Yeah, it is 8. Now we can do C14, C21, and here P3 and P4. 2-1 and 2-1. So this should be 20, I think. Yeah? No, it should be 16. So yeah, it is 16. And then we have this one. What here, Artem, you can use this. Your idea with this minus. Here you can use it.
Yeah.
We can try to implement that. So here. 2 is here you can write subtraction of addition P5 and P1, and here addition P3 and P7, and here 2 and 2. It should be 20. Yeah, it is 20. Okay, so this is good. And now, guys, we only need to have, how to say, we need to join together. So, but how to join? How to join together? So we need to join the matrices. So what we need to join to put it into the result. So I need to create some kind of method, join, and here I need to put C11, for example. I need to put it into result R. It was R, our result, yeah. And then I need to make the coordinates from which place you want to join. It should be very similar to split. Do you agree? So, but now we need to figure out how to implement it. We have 4 minutes left. So, how do you think? Can it be? Can we do it very quickly?
What is join?
Join? Look,
What will it do?
what we have joined. You have splitted those matrices like that.
Yes.
And you have created a matrix C11, C12, C21, C22. You have to make one single matrix out of it. Let me copy the split, and we can try to create a join. So we have a split method. So this is this one. I will copy that and make a join. But when I do join, so what I have in the join, here I have to have a child matrix here, and then here is a parent matrix. Yes. because R was the second one, it was the parent matrix. And now what I need to do, I do the same way. Do you agree? So I just scan the same way, the parent matrix and this one matrix. So it's like the same. But what I put here, I have to put here the parent matrix. I need to change them by places, and that's all. So here I put the parent matrix 2 and 2, and the child matrix just 1 and 1. And then we have the result. Let us try now. We have to have it because it has to put it there. I see it doesn't put anything. So yeah, because I did only one. I did only one join and it put it there. But I need to put another joins because I have join for this matrix. I have a join for that matrix, so I need to have 4 joins. I need to have 4 joins. You understand, yeah? But I need to have them, and I need to put C12, C21, and C22. Yeah? So what do I do with C12? If I put C12, then I need to join from which place? Here should tell from 0 because
n divided by 2.
and here n divided by 2. Yes, n divided by 2.
It all makes sense.
And now it is 2, 1, and I will start it from the second row, so it will be n divided by 2 then here, and here 2, 2, so it will start from both of them. N divided by 2 and n divided by 2. And I think we did it. So let us try to check. Let us try to check. Yes, we did it. It works. But yeah. And I want to check now with larger matrix, 4 by 4. It is more interesting. And I have the previous one. So this one I think is this one, but I have the previous one is here. So I just want to check this matrix. I will put here a 4 by 4 matrix, multiply by 4 by 4. We will receive here result, and we'll compare with that because this one is works for sure.
Can you please show join again?
Yeah, join again. Yeah. Okay. So here, join method. Yeah.
Yes.
It is totally the same, only I changed. I make the parent matrix and I put all these matrix from this child matrix put in the parent matrix starting from the necessary thing, and that's all. So it's like totally the same. If you have a split, you can see I changed the places here, and that is all.
Yes.
And that is basically all. So now let us put 2 matrices together. So here
It gives me
an
an exception.
exception. Okay, maybe some of you want to come and make it the 4 by 4 matrix in my code so that you can run and check how it works. So what kind of exception it gives you? It index 1 out of bounds. So it means that you have here C11, but can you show me your join method? Maybe you change it, no, yeah. You have parent matrix here and child matrix here, but you have to change them by places. Yeah. Because, yeah, but here is P, C, yes. Now it should work. Great. So now let us finish that. So we have to check and then we finish with that. So online guys, was it understandable?
Pretty much.
Okay.
essentially just took a formula and digitalized it.
What do you mean?
We like took a formula and we digitalized it.
Yeah.
Okay.
Yeah, and this Strassen algorithm, it is a little bit different. You can read also in the book, in the page 75. This algorithm was made by the Mr. Strassen, the German mathematician and algorithmist. It is working better when we have large matrices. It computes it faster. And if you don't know, then nowadays we are modeling a lot of things in computer, and we need to multiply matrices all the time. And if you multiply the big matrices, you know, MATLAB is doing this inside, and there are special kind of libraries. They already have this Strassen algorithm implemented there. So if you multiply two matrices, you can use it by Strassen, or you can use another also algorithms to do that. And they produce a faster, and when you have a matrix which has 1,000 row by 1,000 rows, it is much faster than you have usual algorithm like A times B, which we programmed in the second lesson. So let me check it and then we finish. So, or maybe, you know, like that, let's do that as a homework. If we have this ready code, I just give you a homework not to explain this algorithm, but you just put 4x4 matrix and just check whether it works or not, and compare it with the previous matrix, and just record a video and upload it. And it will be fine, yeah? So if you have some problems, then you can try to show how you solved it, and so on. So I'm just uploading this to Moodle. Okay.